You want me to disconnect now? Or, when you hang up now? Hello, hello, hello. morning, everybody. We're going to give everybody else maybe about another 3 to 4 minutes to join, and we'll be getting started. How's everybody doing today? Well, I actually posted the link for the chat. So I actually posted the link for a whiteboard. I see everybody has joined it. So let me know if everybody can see the whiteboard. Has everybody been able to see the whiteboard? And has everybody joined the whiteboard? I keep forgetting that there's a delay. Alright, we're going to go ahead and get started. Yes, you should download the whiteboard. I can't hear any audio from it. Are you able to hear me now? Can you hear me now? Are you able to hear me? What about now?
Can you hear me better now? Hold on for just a second. Can you hear me now? Oh, that worked. All right. Perfect, perfect. Yes, go ahead and download the whiteboard. Well, perfect, perfect. Yeah, go ahead and download the whiteboard. I'll be doing a little bit of teaching off of that as well. Just let me know if y'all can see it. So all the videos that we had on the last that I did last week, I'm breaking them up now and editing them so that y'all can watch them in sections and review them as you go through the book as well. We'll be going over a little bit more binary today to see what everybody remembers. And we're going to start going over installing, configuring, and troubleshooting display and multimedia devices. Yeah, I think my audio was crazy just because the board is reading differently today, and I just had to switch it over just to my microphone. Let's go ahead and start installing, configuring, and troubleshooting display and multimedia devices. Was everybody able to get the book? All right. We're going to go with yes. So in this one, we're going to start talking about displays. We're going to install, and this is about installing and configuring display devices, troubleshooting display devices, and install and configure multimedia devices. So these the exam objectives are to explain basic cable types and features and their purposes. And given a scenario, you're going to be able to install and configure motherboards, CPUs, and add-on cards. And explain the purposes and uses of various peripheral types. So display device types, we have monitors, projectors, and VR headsets. So the first type of monitor we're going to go over is the legacy display types. Most of these you will not see anymore. Some of them are still around, but most of them you will not see anymore. The CRT are the really big old devices that you would see. Those were back in the 90s. They look like the old TVs. Those you will not see anymore. Those are, for the most part, have been completely phased out. Thank you for that. I will fix that later. So flat panel LCDs, they use digital signaling. They're thinner and lighter, and they use less power. LCDs, even from monitors to TVs, have been a standard over maybe the past 15, 20 years as they've come in. Then LCD that's backlit, meaning the light either comes from the edge of the screen, like from here, the edge of the screen, or will come from the back. Before, CRTs used to have a big light that shined in the back, and then the colors would fix themselves on the screen coming to the front of the tube. So it's a small tube in the back with a bunch of with all the RGB colors, and it would shine forward. That's where you would get some of the burn-in or things like that. That's why we have screensavers, because the tube would shine a light so long, if just one image stayed up there, then that image would just stay on the screen and ghost. That doesn't happen as much anymore. It would do it on LCDs as well, but now that we have LED displays, it doesn't happen almost at all. But screensavers are still a staple because of that. LCD stands for liquid crystal display, and LED stands for light emitting diode. And OLEDs are organic light emitting diodes, which means that they have deeper blacks and they have a better color that comes out. So we do have digital projectors, or a video projector. It's a large format display. And now they used to have CRT ones. They don't have them anymore. You have LCD, DLP, and now you have LED, which is using the 4K system. VR headsets. There are two big ones in the industry right now, which is, well, you have three of them. You have Leap, you have the HoloLens by Microsoft, but the one leading the pack right now is Oculus, which uses the Samsung Gear VR. Some of them use your phone inside of a headset, but the Oculus has it's called the Oculus. It's the well, I'll get back to you. It's the Oculus. We have the Oculus Go, and then there's one more that they just released. It's about $400, but it's the closest to VR that you'll get without having a big machine tethered to you. It gives you sensory input from computer applications. You use handheld controllers. Used for gaming. Some people use it for meetings. There's starting to be a lot of social networking around it as well. Display device settings and features. Resolution and analog digital output, screen size and aspect ratio. We're going to go over refresh rates, meaning that how fast does the screen refresh itself. Brightness, contrast ratio, and illuminance. The viewing angle. This is why some of the screens now, if you see some of the longer screens that are curved, it helps you with better viewing angles from every angle of the room. That's where they got the curved TVs or the curved screens now. XGA, that actually stands for Extended Graphics Array. And then HD stands for high definition. So let's go over some of those different resolutions. Now, the aspect ratio means like 16:9 is your normal widescreen TV. 4:3 is what the old CRTs were. So 5:4 means it's more of a square display. 6:9 means it's more of a rectangle display. 16:10 means that it's extra wide. So you have 1280 by 800, which is a lower resolution. For WXGA, which means wide extended graphics array. Then you have SXGA, which were some of the 4.3s. They just extended it out a little bit more, so it ended up being 5.4. So that's still a square display. So that's 1280 by 1024. That stands for super extended graphics array. HD is still 16:9, so that's 1366 by 768. Then you have the wide super graphics array, which means that they just extended the height by 1, which means it's 16:10 instead of 16:9. So 5 is the width, 4 is the height. HD plus is 1600 by 900, meaning from here to here, those pixels are 1600 by 900. So you're going to get 1600 across, 900 down. Full HD is 1920 by 1080. That's where you get 1080p from. QHD. And then you have 4K ultra high def, which is the 380 by 2140. Display device connections and cables. Many types of connectors and cables, video adapters and devices that can support multiple cable types. So most of the time when you look at the back of a TV or the back of a monitor, you're going to get tons of different display connectors. Sometimes you'll get HDMI, DVI, or you'll get VGA ports. So you have the analog to digital conversion sometimes that needs to happen, or digital to analog conversion. So those are actual adapters that you would put on, or sometimes the screen itself will actually make the adaptation. So let's go over a legacy port, which is a VGA port. It's still around. The lower end quality of it is about 800 by 600, but the higher end quality you can get about 1600 by 1200. It is a 15-pin D-shell connector with screws. What that means is that right here, if you look at any VGA port, it will have 15 pins. So this is 5, 10, 15. That's how it always looks. And normally they code it as blue so that you know that it's actually a video connector. It does only send RGB. And the cable length is normally about 5 meters. High quality cable might can support up to about 30 meters, but normally it's around 5 meters. It's a shorter cable. Digital visual interface. This was one of the first HD cables that actually came out. So it was designed for use with flat panel displays. It's actually being phased out right now, so DVIs you won't see a lot. DVI-A looks something like this, meaning that it's only one link. It is still a single link, but it was the oldest one is the DVI-A. Then you have the DVI-D, which was a single link that looked like this. Then the DVI-I and the DVI dual link, which really had more links in it, meaning that it can connect to one of more different DVIs. Like this one sends off different signals because of where the pins are adjusted at. This one sends off different ones because of where the pins are adjusted at. So a DVI-D can only go to a DVI-D, and a DVI-I can only go to a DVI-I. But once you get into it, so DVI dual link can accept this one or this one, and a DVI single link are here. And what it really means is this middle part means that it's only a single link. A dual link means that it's sending more signals across. Let me correct myself. So the difference types is DVI-A is only analog. DVI-D is digital only. DVI-I does analog and digital. A single link is 3.7 gigabits per second at 60 frames per second, and the dual link is 7.4 gigabits per second at 85 frames per second. Any questions about DVI ports or VGA ports? All right. High definition multimedia interfaces. So this is the common one that's out now. Most if not all devices have HDMI. It's used in consumer electronics and computing. It supports digital video and audio streams. The versions support different bandwidths, meaning version 1.4 added 4K support, and version 2.1 supports up to 10K, which means 10,000 lines all the way across. Right now, the highest that's even seen on the market is an 8K TV. And the highest monitor you will see on the market is about a 4K, is a 5K TV. I mean, a 5K monitor. Type A has 19 pins. Type B is a 29 pin for dual link, but it's most commonly not used. The Type C is a mini HDMI, and the Type D is a micro HDMI. And right now, like even to get my video, I'm actually using one of the micro HDMIs. So this is what an HDMI port looks like right across here, or where all the pins are located. So, and then that's what a mini HDMI look like. The cable ratings, you have a Cat 1 or Category 1. Remember that for later, because we will be going over the different categories of network cables. So when you see Cat 3 or Cat 4 or Cat 5, those are referring to the categories. So a Cat 1 HDMI cable is a standard HDMI cable. A Cat 2 is in high speed cable. Then you have the premium high speed and the ultra high speed. And they are backwards compatible with DVI-D, meaning that with an adapter, there is no conversion that's happening. DisplayPort connectors, there are digital AV interfaces developed by VESA. Some of them have it. As I said, it's a royalty-free HDMI alternative, meaning that if you put it in your device, you don't have to pay any royalties on it. HDMI, you actually have to pay royalties. So DisplayPorts are just about in every device now. They try to include it in, just because some devices, like even my Microsoft Surface, uses it actually uses a mini DisplayPort. It's package data transfer, so it's similar to PCI Express. The lanes have to be different for data rates. So each lane can be allocated as 1.62, 2.7, or 5.4 gigabits per second data rate. The maximum data rate for a 4-lane link is 17.28 gigabits per second. So it can support 48-bit color, 3D, 4K ultra high def, and high def. So DisplayPort support copper and fiber optics. It's connectors. Means that it's actually a 20 pin right here. So there's a 20 pin connector. It enables DVI-D and HDMI devices, and it has mini display. So let's go over Thunderbolt and USB-C. Can somebody answer me if Thunderbolt and USB-C are the same? So the emerging trend is to start using USB-C. That's because USB-C can carry HDMI and DisplayPort signaling, but most often it's seen with Thunderbolt 3. So these are the video adapters that I was talking about, where, as I said, that there's a conversion that happens inside the adapter. So when you say HDMI is still compatible with DVI-D, it really means that there is no conversion. It just passes through. When you're talking about VGA going to DVI-D or digital, there is actually a conversion happening in here to turn an analog signal down here into a digital signal over here. So these will pass through. These will make a full conversion. and they do have Thunderbolt to DVI, which is a set. These are still analog. I mean, these are still digital, so there is no conversion going through over here. A video card, correct, Miss Kim. A video card interface between graphic components of a PC and display device. They might use system CPU and memory, but a lot of GPUs or graphic display cards or graphic processing units, they do have their own processor and own memory most of the time on board. Um, on every mostly on every PC, it is actually integrated at this point, so it's always integrated onto the motherboard, especially on low end PCs. But high end PCs will actually have it separate because the memory and the processing power of a GPU that's separate is actually, it can render faster. It can do a lot of other things faster to make your gaming experience better. And it's mostly on gaming computers. So GPU, graphic processing unit. And we're gonna go over this, but um, the clock speed is a is one thing that, how many times per second can it process? Shading units, meaning does it do correct shading of how the world actually looks? The frame rate means how many frames per second can it move? The 3D cards actually need more memory, so most of the time it has onboard memory from 2 to 12. Most of the time it's PCIe at 16 times 16, meaning that it's 16 lanes moving back and forth. There's at least one digital interface supported, and the APIs is normally DirectX and OpenGL. We'll go over those a little bit later when we start talking about software. Configuration tools, most of the time, they're all plug and play. System firmware, setup, programs. Sometimes if it if the display that you're setting up is a little bit more, you can get a little bit more complicated with it. It will have its own program and own firmware that goes in on the computer. Um, Settings such as resolution, if it's multiple displays, color enhancement, 3D enhancement, OS tools like Windows setting or control panel, vendor configuration utility, monitor controls and on-screen menus. I can actually show you with mines. So I can actually go into my display settings. This is what it looks like on the computer. If you see right now, I have 3 actual displays, and there's nothing on here. I have 3 displays. We can adjust the resolution. And just remember, the lower the resolution, the larger everything gets. The higher the resolution, the smaller everything gets. That's why if you have it at its smallest, you might want to change the text size to 200 or 300, which actually makes it a little bit more readable. Um, and we'll go over these settings when I start going over Windows. But this is what the display settings look like inside of Windows. If this was a different computer, because I'm actually using a Microsoft Surface at the moment, this was a different type of computer, which had a different graphics card, then you would see something extra like Intel show up, or um, something close to that. So as we talked about multiple displays, as I said, you want to either duplicate the display, meaning that whatever you saw on the main screen is going to show up on all the other screens that you have, or you want to extend the display, meaning that what I'm doing right now with those three displays that you saw, we were actually extending that whole display out, meaning I have three different screens and I can move my mouse around to all three different screens. Um, and then you also have show only on one screen, meaning that I don't want to use my other screens right now. I just want to use that first screen. Um, you can actually do multiple displays by daisy chaining display ports or Thunderbolt monitors. That's because, as we said before, this data transfer rate for DisplayPort and other video cards. Let's go back to that slide. When we talked about each lane or the maximum data rate of a 4-lane link, it means that when I daisy chain it together, the video can actually travel across that without any loss. And I just showed y'all that. All right. So look at the following exhibit and what two types of display cablings can be connected for this laptop. Well, okay. So right now, this right here would be the VGA port and HDMI. So this one is the DVI dual link and a display port. So that is a DVI and a HDMI cable. So a customer is shopping for a computer game for her and her daughter and wants to know if you can explain the reference to DirectX on the packaging. So DirectX is Microsoft API, which is an application programming interface for 3D and multimedia applications. The software, such as a computer game, will specify the minimum DirectX version. Graphic cards must support the version ran by the game. That's why you have OpenGL, which is an open graphics processing or programming interface, and DirectX is Microsoft's. So if you're configuring two monitors to an extended desktop mode, what should you configure in the display box? You ensure the layout of the displays matches their physical location. And what that really means is when I do this, this is actually the physical location of my screens. So I have the two at the top and then the one at the bottom. So these are actually the physical locations of these actual screens. And it means that when I move my mouse, I can move it all around. And it moves fluidly. Installing a graphics adapter. Common display issues are no image displayed on the monitor. Um, this was a big issue when I first started building computers. Um, and most techs will actually ask you this question, say that you're plugged into the display, nothing shows up, but the computer is on. What could be the issue? A lot of that has to do with the RAM. If the RAM isn't seated correctly, the monitor will not show. So that's one of the biggest troubleshooting. Image is dim. You can actually adjust the brightness. If it flickers, you might want to check the cabling. Low resolution or color depth could be a bad cable. Could be that the firmware needs to be installed. Images or icons are oversized. Could be a firmware or driver issue, or it could be that the cable is bad, or you need to adjust the resolution or the color patterns. Dead pixels means that the display is going bad. That means that you have black spots inside of your screen. The image is burned into the monitor. That, as I told you before, had to do a lot with screensavers. So if one image stays on the screen long enough with an LCD or CRT monitor, it actually burns that image into the monitor. Unexpected objects or patterns appear on the monitor. Overheating, protected content. Um, as we said before, for no power, I mean for no image, you're going to verify that there's power to the monitor. You might want to try reseating the RAM. Use OSD controls, meaning that sometimes it might be on the wrong input. Your monitor might have different inputs, and it might actually be on the wrong input. Um, or try using another monitor. If that works, maybe that monitor has went bad. For image quality issues, it said you'll check the video cable, adjust the hardware, adjust resolution. Maybe the refresh rate is too low. Display configuration, low resolution or color depth. You want to increase the resolution, increase the DPI settings. Um, Verify no zoom tool is in use. Sometimes the monitor can actually be set to zoom in so that the picture comes in a little bit larger for people with bad eyesight to see. Um, for color rate issues, there's actually screens that you can actually adjust the gamma with, display color, and we'll go over that once I go over a lot more of the Windows configuration. The adapter or monitor faults for dead pixels. For dead pixels, try software utilities designed to reactivate them or gently start tapping the affected area of the screen. Most of the time, when you're getting dead pixels, it just means that the diodes behind that is actually just dead and the screen is going to go bad. For burn in, you got to always make sure you're using screensavers and power saving modes. For unexpected objects and patterns, static artifacts caused by a faulty adapter, persistent images on TFT monitors. Try shutting off the monitor for several hours, meaning that it might have been reading an image from before. Verify that the graphic card, the driver, the API version are supported. Try disabling the video effects, and make sure that you update or install all the drivers and or firmware. Um, Check the display adapter and driver if you experience the BSOD. BSOD stands for blue screen of death, and we will go over that once we get into the second part of 8 Plus, which is 1002, which starts going over all the Windows errors. So imagine the device you installed is not showing the color blue. The first thing you would test is the display cable. Make sure the original cable is properly inserted at the computer and the monitor ends. Try replacing it with a known good version of it. If that does not fix the problem, inspect the ports and signs for damage. What's the most likely cause of flickering display, especially on a CRT? It can be if the refresh rate is too low, meaning that the screen isn't refreshing itself fast enough. On a TFT, it could indicate a problem with the backlight, meaning that it's not backlighting correctly. And you should also verify that the connectors are secure and rule out any cabling problems. Normally, with a flickering display, most likely it's the cable. It's very rarely that it's the screen. Most of the time, it's either the cable or the connector. So if it was pushed up against something, or the cable was ever extended or bent or broken in the middle, it might cause that display to flicker because it's not receiving the signal at a constant rate. That signal is getting interrupted as it comes in and goes out. What should you do if an image from a projector appeared narrower at the top than at the bottom? You ensure that the projector lens is lined up with the whiteboard. That means that you might have to adjust the keystone where the image is wider or smaller at one end, because with the projector, you got to remember that it's going out. So as it's going out, you want it to come back. I mean, there might be an angle where it might look smaller at one side and larger at the top. So you might want to adjust the keystone to where you're pinching the screen in a different way. I don't know if that helps everybody understand it a little bit better. You need to set up a system to show content protected video, which display connector types are suitable, which is DVI, HDMI, DisplayPort, and Thunderbolt. Troubleshooting monitor issues. Most computers have an audio subsystem, which is a different sound card. The audio chip for the basic sound card is actually on the board. Expansive cards have better features, so it normally has onboard RAM, just like a display or graphics or a GPU. It will have better features. So onboard RAM, wavetables, might have multiple jacks. It will actually support more sound APIs, which is Direct Sound 3D, OpenAL, or EAX. So if you look, pink has always been for mic in. Green has always been for audio out. Blue is always audio in. And these two that you'll see is normally HD or surround sound audio out, which is like left and right or subwoofer. Some things like that every once in a while. See, carries right to the rear speakers of the sound system, and these carry to the subwoofer. I say green, they say lime, but it's the same thing. This is called an optical out cable, meaning that it actually travels over light. We'll go over optical cables a little bit later when we go over fiber optics, which is another type of network, cable as well. Playback through headphones and speakers can be analog or digital sound. There's either mono, which means one. So like my microphone is in mono mode and not stereo. And then you have stereo, which means that the left and the right. So my headphones are coming through the left and the right sound. And then you have surround sound, which means it might have a subwoofer, a rear right, a rear left, and then a left, and then a right, to make sure you get that full surround sound. So here's what surround sound looks like: surround left, surround right, surround back right, surround back left, the front left, the right left, the subwoofer, and then the front center to give that surround sound feel. Musical instrument digital interface, which is MIDI, allows a computer with a sound card to drive MIDI compatible musical instruments for a synthesizer to drive computer audio applications. There's a lot of audio applications that we use MIDI for. Um, and what it does is MIDI is actually just an input. And once that we call them digital audio applications, DAWs. Once they actually receive that MIDI input, we can put any sound over it, and we can go over them a little bit later as well. Um, so for synthesizers and electronic drum sets, we can actually the information about the sound is shared, but not the sound itself. So as I said, the sample, the volume, the pitch, the tempo, all that is recorded without any type of sound. You can actually put any sound you want over that. So many devices use a 5-pin DIN connector or a USB connector. Sampling resolution, higher sampling rates and resolutions provide more accurate sound. Distortion, you can actually take that out a little bit. MIDI ports connect different types of recording gear. Headsets contain headphones and microphones. We use those for VoIP calls and meetings and audio conferencing applications. They usually connect with USB or wireless Bluetooth. The Windows Sound Control, how we adjust the settings are through the Windows Sound Control settings. So some keyboards you can actually control the volume. Some laptops have function keys which allow you to control the volume. The Windows Sound Control panel, Windows Setting panel, you can actually control what comes in and what goes out. Right now, the webcam that I'm using, it's actually not a webcam, but you can set anything to use this webcam. It records video and audio. Most of the time, it's low rate. This is actually a different type of video card that I'm using that is actually plugged in, and I actually have a GoPro plugged up using this one. It's used for online video conferences, website feeds, and surveillance. It's either integrated or external. Most of your low-res ones are integrated. Most of your high-resolution ones are actually external. And that's what it looks like. Some of them do look like that. Some of them don't. Digital cameras. I think everybody's used one of those for still pictures or video recording. Um, some of them don't have a viewfinder. A lot of them do. They're they're available in various models. Um, so less than 1 megapixel for on-screen viewing, 1 to 2 megapixels. Poster prints. This is a very, very low end, because now even your phones carry 21 megapixels, 30 megapixels, which means it's a very large. Like if you can put it to where maybe 4 to 8 megapixels or higher prints poster pages that are 30 inches or larger, just imagine the print of a 13 or 14 or 22 megapixel camera that's actually in your phone. It gives you way more definition, and that's why the photos are so much larger, is because it's carrying so much more information. What size and color connector should you look for to plug in a basic microphone to a PC? A 3.5 millimeter jack, which is often color coded pink. You have installed a new sound card in a computer designed for home entertainment. What type of connection would you use to connect a digital surround sound speaker system to the new card? The optical or coax cable. Coax audio uses the RCA connectors. Optical or SPDIF is what we normally call them. Is also or sometimes connect or referred to as a um, TOS link. So those are the optical cables, or you have the RCA cables. And sometimes the entertainment just puts audio over HDMI. What type of speaker unit is the point 0.1 of a 5.1 or 7.1 surround sound system, and where do you suggest that speaker be placed? So the point 0.1 is the subwoofer. And you start with placing it in the front of the room, and you try to figure out where that best sound is. There's a lot more that goes into that you really do not have to know. What type of interface would allow a software program running on a PC to operate a synthesizer connected as a peripheral device? The answer is a MIDI, musical instrument digital interface. What sampling rate from a sound card would you want to be able to record CD quality sound? That would be 16-bit or 44.1 kilohertz. Normally, it's actually recorded at 96 and 24 and downgraded to 44.1 so that you still get the best sound. And that is the end of that one. So today was a little bit of a shorter class because next week we're going to go through another 140 slides, and this is going to be more on troubleshooting and configuring storage devices. And we'll be able to go over a lot more with RAM and CPU. And y'all actually let me know if you'll want to do this during the week as well to kind of make it through a little bit faster. But other than that, y'all can call me with any questions that y'all have so far. Email me. I can actually answer anything that you need. As I said, these videos will be up piece by piece so that you can start reviewing them. I'm working on editing them now to make sure that they get up with a little bit more illustrations.